It just seems so simple driving an LED. You've got your microcontroller, current limiting resistor, LED. What more could you need? Well, if you're going to be able to get all these forever, then I suppose you're done. But when things happen, you need a better design that's more resilient to supply chain issues. This ain't it. And I'm going to show you why. So first thing I'm going to go into is a few different microcontrollers and show you I/O current. So in our normal 18 mega 328D, max current you can do in a pin is 40, but the maximum, oh, my kitty, she needs lovin's. I have a cat named Snorkels. She's very cute. Okay, so max DC current, 200 milliamps. So your 20 milliamp LED already uses 10% of your power budget. Big deal? Maybe, maybe not. Something you got to look up. Our next chip, let's look at a PIC 24 blah 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 blah. That looks more like a serial number than a microcontroller, but whatevs. Okay. This particular one gives thermal operating conditions. So, something to consider. Microcontroller, lots of current, lots of heat. I don't like that. But sourcing here, instead of 40 milliamps, it goes down to 25. But max current, 300. Okay. Then if we go into this STM32L0 and blah, 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 we're at 16. Eee. That's not much. And you can only use 100 milliamps max. Ugh. Thermal characteristics doesn't really give you much. So where I'm going with all this is if you have a problem with your LED and you need to switch it out, or you need to switch out your microcontroller, you gotta look these up. I had one where this number was 10 milliamps. And because of that, they used a really not common LED. Low current, high brightness. So when you have supply issues on that type of LED and you have that constraint of your microcontroller, it was a day ruiner. Just put it on that. And it was a customer facing LED. So now what we're going to do is we're going to show you what you should do. So instead of direct connection, just go through a MOSFET. It doesn't even have to be a good one, because you're only going to have 15, 20 milliamps, but this gives you flexibility. For starters, this LED can do more. You're only limited by whatever your 5-volt supply can do. And that number's a lot easier to look up. And yeah, switching the resistor, no big deal. Switching the LED, no big deal. Supply chain stuff happens. There are other vendors for all of these. There are not a lot of vendors for an 18 mega 328P. However, I am forgetting one thing. I may make a separate video on this. Don't forget the gate resistor. Don't forget your gate resistor. The short version, There's capacitance here. What does capacitors do when you first turn them on? You short circuit. So no, that means lots of current. No good. Use a current limiting resistor on your gate, otherwise known as just a gate resistor. And I'm a big fan of bomb consolidation, which is the fancy word for use stuff that's already on the board. Limit your number of unique components. So, this was a quick video, but the summary. This is good from a design perspective. It will work. This is better from a manufacturing perspective. It will work forever. So always follow good design practices, people. It'll save your butt in the long run. This is Steven, over and out.